Hello everybody, Justin Miller, Rockstar College Physics here. Not in front of the camera, I'm actually behind it right now, but we want to start looking at some images formed by reflection. So perhaps you notice there's three mirrors that the camera's pointed at, and I'm back here behind the camera in those three different mirrors. So we got one mirror on, well, let's say, is that your left? It's on my left, so maybe it's your left. That's my left right now. Uh-oh, my left in one is the right in the other. Well, at any rate, we got a concave mirror, we've got a planar mirror in the middle, and then on the other side, we've got a convex mirror. And I'll have different correlations with image formations, but it's all due to reflection. So you see me in the middle, I'm nice and upright. Let me come and take a little stroll over towards here. Whew. I can see the camera, you can see me, at least in this one. Let me see about this one here. Oh, there's the camera. I see the camera, you see me, because light for me is reflecting off of this mirror and going into the camera. The camera's kind of like your eye in a sense. You see in this one. All right, I see the camera now. Upside down, it's right there. Let me get a little bit closer. Still see the camera. It gets a little bit blurry, but let me come over this way. Let's see if I can find it again. Oh, there you are. Hi, look it, I'm upright now. And I'm kind of magnified, aren't I? Ooh, that's a little scary. But at any rate, you're seeing me because the light from me is reflecting off this mirror, going into the camera. Let me come back here. Uh-oh, I'm upside down again. Hey, that's crazy, huh? Ooh, this one, I'm always right side up. A big view of the whole lab room here. Ooh, what a mess, what a mess. We just got this one here. It's planar mirror. Stay upright and has this sense of depth to it too. That's kind of one-to-one. Well, we're gonna be looking at these types of mirrors here and getting a sense of image formation. So let me turn something off here and I'll be right back. Alright, so we want to start looking at some image formation. We're going to start out with a nice planar mirror. Let me get you in there. There you are. Hi. Well, how's the image formed? Well, again, light from me that's being reflected off of me due to the lights in this room are striking this mirror and obeying the law of reflection, which we've looked at before, equal angles. And if I have this planar mirror oriented in the right way, that angle will put the light right into the camera. When you see me. Fantastic. Well, let's just kind of look at how that takes place in a nice simple scenario here. So we're going to be looking at images formed by reflection. That's right. So what can we do? Well, let us take a nice little planar mirror and just have a little for instance. So it'll be good to take some things here. Let's say that we've got a mirror. So this is going to be our mirror, and we're going to put some alignment axis, which we generally call a principal axis, in order to kind of line things up nicely. The principal axis here is just something, again, so we can keep track of where things are relative to the mirror on either side of it. And the principal axis goes through the mirror at normal incidence. That is, there's a 90-degree angle between the principal axis and the mirror here. So we'll get used to the principal axis over time. Right now, let's just go ahead and draw some things in. So I'm going to go ahead and take an object that is 8 inches away from the plane of the mirror. It's going to be right there, and I'm going to draw it in so that it's on the principal axis, extended upward, And we're going to make it, let's make it 5 inches high. We'll make it a little arrow so it has some regard of orientation. And this is going to be object. So generally when we're doing depictions of images for them, we're going to use object arrows because they point in a certain way and they have some sort of extension to them, and it's just nice to be able to look at. So what we're going to do is we're going to look at light emanating from the tip of this object and see how that light interacts with this mirror, reflecting off of the mirror. So that's going to be good to go ahead and take some, let's use purple. No, let's use blue. All right, so we're going to look at some paths of light to see what they do in terms of reflecting off. So there's going to be a path that just goes parallel to this principal axis. And what's it going to do? Oh, it's going to hit the mirror. And then it's just going to reflect back on the path that it originally was taken. So we've got this path here, this ray, if you will. Incoming ray, reflected ray, strikes the mirror, just reflects off. Normal incidence, it just hits at 0 degrees with respect to the normal and reflects off at 0 degrees with respect to the normal. Let's look at another path here. Let's look at one that goes from the tip and strikes this location here. Try to be careful of this. We're going to look at light ray. Hits right there. All right, so light ray strikes right there. What's it going to do? It's going to reflect off at equal angles about that point. Let's see if I can get a decent measurement of what that angle is. Try to reproduce it. That looks like just over 50 degrees. 10, 20, 30, nope, sorry, 30, 33 or so. So let's do this. Put this here. Careful once again. So we've got 10, 20, 30, a little bit over 30, 10, 20, 30, a little bit over 30. Let's say that it looks like it's about right there in terms of equal angles. And I'm just going to connect those up. And this would be the reflected path. Now really there's a big cone, if you will, of reflected paths that light rays will make regarding light coming from the tip of this object, excuse me. So someone's going to hit here and bounce off that way, someone's going to hit down here and bounce off down that way, and everywhere in between. So we could draw more of those. I could say that there's one up here. This is where I probably won't be as careful with, but it goes like this and reflects off, and likewise some down here, strikes the mirror and reflects off. And how do we end up seeing the image of this object in the mirror? Well, the light that's been reflected off has to enter our eye. So if we look at this, if I'm, for instance, down here, this ray right here can enter my eye. And what do? I see the image. I see the image in the mirror. And really, as long as some light after it's being reflected off of this mirror can enter my eye, I can see the image of this tip. Because again, the light from it has to be entering my eye. But where is the actual image itself? Well, let's look at something. Let's look at how these light rays trace back to a point of, well, intersection in a sense, where it seems like light's emanating from. So if I start tracing these light rays back, we'll grab another color here, on the other side of the mirror where they physically do not exist, well, we can trace this one back. This one's going to trace back along that path. This one's going to trace back along this path. And we could do this for a bunch of them. This one would trace back along this path. We looked at the reflected path. I guess I could draw that in there at this point. Reflected path would be going up like this. And this one would trace back along this path. Again, I can draw in the reflected path here. Be done like that. And here is the trace back path. So this again to be like the reflected path. All these are the reflected paths here. Incoming, reflected, incoming, reflected. And as long as my eye is somewhere where some of this reflected light can reach, I can see the tip of this arrow. So where do I see it? I see the tip of the arrow in terms of the image right here. That's where it looks like the image is. That's where the image actually is. If you ever look in a planar mirror, there's this sense of depth, right? You can see that I'm closer to the mirror than the camera is. Assuming that you can see them both right now. Why is that? Well, it's all about where light either is physically emanating from or where light seems like it's coming from. Light seems like it's coming outward from this point. Your eyes trace back these paths to the points of intersection where light is either actually coming from, like from the object, or where light seems like it's coming from, in this case, the image. So what would we do, or what could we do? We could do this for every point along this arrow and translate it down to the principal axis here. And what are we going to get? We're going to get this. We're going to get a translation of image down to the principal axis. And there we would have our the image. So we're looking over here in the mirror. Maybe this is us. This is our face here, and we see our face over here, looking back at us. And as long as the light from that can enter my eye, maybe I'm holding an object, the light from that can enter my eye, I can see it in the mirror. Where do I see it? I see it there. Sense of depth. Now, if we went and looked at some measurements here, and said, well, if this was like 8 inches, well, this should be, oh my gosh, that's 8 inches too. There's this preserved 1-to-1 depth. And well, the height of this is the same height as that. When you look in the mirror, everything's sort of preserved. Planar mirror. So this is kind of what we want to be looking at. So ultimately, this is what we have. Images are formed where light rays either physically intersect after reflection or trace back to a point of intersection after the reflection. That's it. So in this case, they trace back to this point. And we'll get into differences between physically intersecting and tracing back later on. We just wanted to introduce this. So I'm going to stop this right here because I want to take a couple pictures of this and then we'll regroup here momentarily. So bear with me. See how the image that I drew overlaps with where the image actually is in the mirror? That's what I wanted to show. That's it.